Welcome to this explainer. You know that feeling when you're just completely bogged down by mind-numbing repetitive tasks at work, and you think to yourself, there has got to be a better way to do this? Well, you are in exactly the right place. Today, we're unlocking a completely new capability for you. We are going to dive into how you can effortlessly automate those mundane tasks by learning to speak directly to your computer. It's all about building this incredibly powerful partnership, and we're going to do it through Python.
Okay, let's jump right in with a pretty staggering question. Imagine you have a personal assistant standing right next to you, and they're just constantly asking, what's next, what's next, what's next? But they're asking you that 3 billion times every single second. Crazy, right? But that is precisely what the processor inside a modern computer is doing. If your machine is rated at, say, 3.0 gigahertz, it is literally asking that question 3 billion times a second. How could a human being possibly keep up with that? I mean, it would be absolutely impossible to answer them live.
Here's the secret, though. You don't answer them live. The solution is actually beautifully simple. You write your instructions down in advance. Because obviously, we can't shrink ourselves down to 5 millimeters tall, jump inside the computer, and shout commands at lightning speed. So we write out a script ahead of time. And that act, writing those instructions down, working through the logic and getting it correct, that is exactly what programming is. So let's completely reframe how we think about this machine sitting on our desks.
Section 1. Meet your digital assistant. I want you to think of the core hardware of your computer as a super eager personal digital assistant. It's built from the ground up to do absolutely nothing but wait for your command. It basically just sits there, endlessly looping, what next, what next? When software engineers add an operating system and applications to that raw hardware, it transforms into this highly capable assistant, totally eager and ready to take all those repetitive tasks right off your plate.
And you know, this is exactly why humans and computers make such a perfect team. Think about it. Imagine trying to count how many times the word to appears in a really long book chapter. For us humans, reading the text, understanding the emotion, the nuance, that takes seconds. But meticulously counting the words? That is painful and so boring. Computers are the exact opposite. They struggle to understand the deep meaning of a poem, but they can count thousands of words in a fraction of a second. By partnering with the computer, you're delegating the blinding speed and the repetitive counting to the machine, while you bring the creativity, the intuition, and the inventiveness. Now, to really make the most of this partnership, we need to know exactly who, or rather what, we are working with. So let's take a quick tour of your computer's internal brain.
Section 2. Inside the machine.
So, the core hardware architecture of a computer. It's actually incredibly straightforward. There are really just 5 main components working together to process the instructions you write. Let's walk through them real quick so you're completely grounded in the physical reality of the machine you're partnering with.
First up, and definitely the most important, we have the central processing unit, or CPU. It's kind of wild when you realize the CPU is the actual entity we're communicating with when we write our code. This is the very part of the computer that is completely obsessed with asking, what is next, billions of times a second. It is the absolute engine of our digital assistant.
Now, the CPU obviously needs a place to store the information it's working on, right? And it uses 2 distinct types of memory to do that. First, there's main memory. This is lightning fast, nearly matching the speed of the CPU itself. But catch this, it's completely amnesiac. Everything stored here vanishes the exact second you turn the computer off. Secondary memory, on the other hand, is a bit slower, but it's permanent. Think of your solid-state drives or a USB flash drive. It keeps your data completely safe, even when someone pulls the plug.
Rounding out the whole shebang, we have the components that let us actually interact with the machine and the outside world. Input and output devices, your screen, your keyboard, mouse, speakers. And finally, the network connection. It's interesting. From the CPU's perspective, the network is essentially just a very slow, sometimes pretty unreliable place to store and retrieve data. It's almost like a distant form of secondary memory.
Now here is the kicker. Most of the time when you sit down at a computer, it's actually other software engineers who are talking to your CPU. Their apps are basically screaming, pick me or buy me right at you. But by learning to program, you stop just being a consumer of other people's commands. You get to step right into the driver's seat. You get to orchestrate the CPU, the memory, and the network to solve your specific problems. So how do we actually give these commands? Well, we do it by speaking Python.
Section 3. Learning the language. It is such a huge relief to realize that unlike human languages, which, let's face it, have hundreds of thousands of words, Python's vocabulary is actually incredibly small. You do not need to memorize a massive, complex dictionary to start talking to your digital assistant.
Just listen to some of Python's built-in words for a second. False, import, pass, break, in. There are literally only a few dozen of them in total. I think this really proves just how beautifully simple the core vocabulary of this programming language actually is. We call this tiny vocabulary Python's reserved words, or keywords, and that just means when Python sees these specific words in your program, they have one, and absolutely only one, very special meaning. They are the absolute foundation. You learn these few core words, and eventually you'll use them to construct your own custom instructions and even invent your own variable names. So once you have the vocabulary down, what happens next?
Section 4. Telling your story.
Learning to write code is actually deeply similar to learning how to write a story. Seriously. First, you learn the core vocabulary, those reserved keywords we just looked at. Second, you learn the grammar so you can construct valid sentences. And finally, you combine those sentences to convey an idea, or, in the case of programming, to solve a real-world problem. The program you write is simply the story you are telling the computer to get a job done.
This illustrates a really great philosophy from Dr. Charles Severance. He says, writing programs is a very creative and rewarding activity. And it really is. When you first start out, sure, it might feel like you're just learning spelling and grammar. But over time, you catch your stride. You get your muse. You start seeing patterns. Programming shifts from being this strict, rigid, logical exercise into a highly creative process where you are literally designing elegant solutions to analyze information and solve problems.
Which leaves us with one final and honestly super exciting thought. You have a staggeringly fast personal assistant sitting right in front of you, waiting with infinite patience, asking what next 3 billion times a second. You now know that learning its language, Python, is really just a matter of grasping a small vocabulary and writing out your instructions just like a story. So the only question left for you is, what story are you going to write with your data? Thanks so much for joining me in this explainer.